Hey everybody. So there's a few things I want to go through that I feel like would probably help you for the homework over the weekend. So the first thing, and there's three things I think I'm going to go through with you, but the first thing I'd like to go through with you is how to convert from function notation into an equation. So the idea is that if you have a transformed function which has been written in function notation and you want to write the equation of the actual function, this is what we're going to be doing. Okay? So let's suppose that we have a parent function, which again we usually label as f of x. Okay, let's say that that parent function is transformed according to some sort of function notation, which I'm going to write down below. We're going to find out what the equation is for our transformed function g of x. So we have a parent function, it gets transformed according to some sort of function notation. We need to find the equation of g of x. So in this case, let's suppose that f of x is our parent function, which is the parent function for square root functions, and let's suppose that our function notation to get g of x is given by g of x is equal to negative 4 times f of 2 times x plus 1 minus 6. Okay, so this what we have here for g of x, that is basically a set of instructions for getting the equation. Okay. So, what I want to point out to you guys is that since we're taking f of 2x plus 1, you have to remember that what that means is that we're going to be replacing x in our parent function with that stuff, right? So we're going to replace x with 2x plus 1. So that's going to be the first step that we're going to consider. Then I want to point out to you guys that up front we have that negative 4. We're going to be using that to multiply f by that. So we're going to be multiplying f of x by negative 4. And then lastly, we're going to be adding the negative 6 to the end of f of x. So we're doing three things really. First we're replacing x with 2 times x plus 1. Then we're multiplying the parent function by negative 4. And then we're adding negative 6 to the end. Or you could think about it as subtracting 6 from the end. So what's that going to look like? So g of x, the equation of g of x, okay, well again, first thing that we're doing is we're going to take our parent function, f of x is equal to the square root of x, and we're going to replace x with 2x plus 1. Because remember, we're in the function notation here, we have f of 2x plus 1. That means replace x in your parent function with 2x plus 1. So we're going to get the square root of 2x plus 1. So we took the square root of x, which is our parent function, replaced x with 2x plus 1. That's our first step. Then our next step is to multiply that function by negative 4. So we multiply by negative 4 out front. And then we're going to add negative 6 to the end, or basically subtract 6 from the end, and we get that. So that is the equation of our transformed function, right? So up here we have our function notation. And remember, function notation is basically a way of describing the transformations, and it can also be thought of as a set of instructions for getting the equation of your function. But what we have down here, that is the actual equation of our transformed function. So that is the equation of our transformed function g of x, okay? So that's how to convert from function notation into an equation for a transformed function, okay? So the next thing I want to talk to you guys about is identifying a, k, d, and c from an equation. So the idea is that if you've been given the equation of some sort of transformed function, can we find out what a, k, d, and c are going to be, right? So let's suppose that we have, so let's say we want to state a, k, d, and c for the following transformed function. So here's the transformed function. G of x is equal to negative 0.5 times the absolute value of negative 2x minus 4 plus 3. Okay, so upon first look, this looks like it'd be pretty easy, right? You'd probably say, okay, let's see, this is our a value, this is our k value, this is our d value, and this over here is our c value. Well, you wouldn't be completely right, all right? There's some stuff that we got to do first. So let me show you why this is not completely right. So I want you guys to first recall that function notation is given as g of x is equal to a times f of k times x minus d plus c. Now, I want you to take a look at these two, okay, these two guys here. In our function notation, we have k, open bracket, x minus d, and in our equation here, we have just negative 2x minus 4. So in our function notation, it looks like k has been common factored out. Okay, it looks like it's been common factored out somehow, but it doesn't really look like that in our equation. So what we're going to want to do is actually common factor out our k value, and in this case our k value is going to be -2. So we're going to want to common factor in a -2 inside there to make it look like our function notation properly. Alright, so let's see what we get when we do that. So we're going to have -0.5 times the absolute value of, so if we're common factoring at -2, we have -2 open bracket x plus 2 close bracket plus 3. Okay, so notice that that actually is going to change our d value here. By common factoring out the -2, right, we've actually changed the d value from what looked like it was going to be -4 to +2. So this is the correct equation to get the a, the k, the d, and the c value from. So from here it's actually pretty easy, right? So our a value is going to be -0.5. Our k value is going to be -2. Our d value is going to be +2. Pardon me, that should be +2. Let me just erase what we got there. So it should be +2. There we go, +2. And then our c value is +3 at the end. Okay, so that's how to identify the a, the k, the d, and the c values when you've been given an equation. So you need to make sure that it's in the correct form, which means you need to make sure that your k value has been common factored out before you decide what your a, k, and d, and c values are. Okay, so the last thing I want to go through with you guys is just the order that the transformations are going to be applied. Okay, so the order that the transformations are applied. So the idea here is that if you know the list of transformations that need to be applied to some sort of parent function, there is a correct order in which to apply them. Otherwise, you might end up with something wrong. Namely, suppose you had to horizontally translate something to the right by 2 units, and you also had to horizontally reflect it. Okay? If you perform the translation before the reflection, you would get a slightly different graph than if you reflected and then translated. Okay? So there is a correct order in which to apply these. So this is going to be the correct order. So the first transformations that are going to be applied are going to be all of the stretches, compressions, and reflections. And those are vertical and horizontal stretches, compressions, and reflections. Those can all be applied in the same step. So it doesn't really matter which ones you apply of those first. It doesn't make a difference. You could stretch, compress, or reflect vertically or horizontally all at the same time. Doesn't matter. Okay? But those all need to be applied before you make your translations. Okay, so always stretch, compress, or reflect before translating your functions. So this was just 3 things that I feel would help you guys out with the homework. I would highly recommend that you finish watching this entire video before you start on the homework. Other than that, I hope that it helps you out with it anyways. All right, hope you guys have a nice weekend. Take care.